Hello everyone, my name is Ahmad Atamlh, and today I want to talk to you about improving network security and agility using SmartNIC. So I spent the last 3 years working with my colleague Ariel Kate, who is not here today, but I have to give him some recognition for all the hard work we've been doing in the... Are you able to hear me? Okay, better. Thank you. So, going back to that. Improving network security and agility using SmartNIC. Oh, okay. I didn't see that. How many of you are familiar with SmartNICs before I start here? Anyone? Oh, perfect. So we all know that infrastructure in the cloud and in the environment is a big thing, and we always want to improve the way we build our infrastructure to make it cost effective, reducing the power and the maintenance cost we build our infrastructure. If we're going back to the beginning, everything started from calendars, calculators, newspapers, and that we moved that, digitalized it a bit on one machine, and we move on to more services like WhatsApp, which have a lot of infrastructure behind of managing the data of millions of users, video for storage contacts, music, and then so on. So there is a place that need to store and process this data and give the user services. And when designing the infrastructure from security point of view, there is a lot of challenges. The first challenge that are faced when designing this infrastructure is on the platform level. I want to think about what are the modes that you want to support. Where are your threats coming from? And the threats are changing constantly in today's world. There's more sophisticated attack, and attacker capability is getting stronger and stronger. So we're moving toward adopting the zero trust model, where even if I have a data center or edge, I don't know where our machine going to be deployed. It's going to be deployed in one part of the world and the other part of the world. Who knows who I have access to, and do I really trust my admin to go and install whatever he likes on that system? And that doesn't end up with installing an application on the system. It also could be in a more intrusive form, where installing a malicious firmware or hacking the BIOS, installing a new operating system. So we really need to get some measures in place in order to protect malicious activity from taking over the platform, trying to steal user data. And there here where the model of zero trust, when I deploy security in several areas in order to restrict a malicious actor from infiltrating the platform. And traditionally, how this is achieved is by embedding things in hardware, authentication everything, trying to gain some assurances about the platform that is being deployed, that is running the right software, it's doing the right things. And there's more and more security primitive that is coming in place. But that is not enough, because we still process users' data, and processing user data even within data center, you have no idea who have access to the data. Even if you end up securing your platform, your server, there's still someone that can tap on the wire, can see the traffic that is being sent from one server to another server, from a server to a switch, and so on. So we really need to think about how we deploy security everywhere, and where do we draw this parameter of where do I apply security. Now this gets more complicated for a cloud provider in a bare metal case, where you literally give access to the server and complete control over the platform. You can install your BIOS, your operating system, and then it's the Wild West. Why? Because the second the user have that much of an access, he can start intervening with the whole cloud network, and affecting other users, trying to affect the devices on the platform, but trying to infiltrate them in order to persist on the platform. And the typical approach to kind of target this is to have all sorts of security rules, some development lifecycle process in order to try to target those threats and preventing from persisting. And of course, you're all familiar with regulation and compliancy. This is getting more complicated because if you want to store private users' data, you have to guarantee that within some time frame, you end up deleting this data. You can get more of a leeway if you end up securing this data by means of encryption, both storing data at rest and storing data in motion. And this is going to come up and getting more and more severe through the latest attack in the last 2 years. Okay, so if we look at this segment, this is applicable basically to many things, whether it's a high-performance computing, a cloud, edge, telco, financial sector. Everything will need eventually an infrastructure. Everything will run someplace. You will have some user data stored somewhere, and you will be the one responsible for securing this data. And if you do not, eventually you're going to have to pay a heavy price if that leaks. And we're seeing more model, the modern model basically, we're starting to move everything to the cloud. So on top of the application level and the services that we give to the users, we have really a lot of security features and primitives that we need to implement in the infrastructure. And think about one server with the 16 core, for instance, now that it needs to run some code for encryption to secure data in motion, or securing that data at rest, or agent that is trying to detect when a user is trying to infiltrate the system and steal other users' data. This gets much more complicated, and you end up basically, instead of using those 16 core to get to the user or to the service you want to give, you end up putting that for security. So we really want to basically optimize this process and make it better so we can make the most out of our server and host machines and still at the same time deploy good security that is not easily breakable. So the common mode today, what do we know about the network adapter? I just plug and play, and the network adapter is pretty dumb and stupid. It's just move packet from one place to another. And all the kind of heavy functionality, whether it's storage, whether it's SDN or others, is basically present on a host machine. That means it's going to take quite a lot. Now think about the scenario where if an attacker managed to exploit a vulnerability and persist in the system. What does it mean for all my security solution? If I have TLS connections or IPsec connection, that means it's the end of the road for me, because all the attacker need to do is to go and send all those keys. He doesn't need to get all this data. The data can be spoofed, and all you need to do is just basically send the keys. Now, with SmartNIC, you can think about it in a different way, because we take a network adapter and we made it much smarter. That means we equipped it with all sorts of hardware accelerator, some compute, not necessarily in the same compute that a host machine, a server have the same CPU. It could be embedded CPUs on that SmartNIC. And it offloads some of the necessary functionality that can be offloaded to basically a SmartNIC. And I will elaborate on this a bit later. So what is a SmartNIC? I spent the last 10 minutes talking about improving infrastructure and changing the way servers look. So a SmartNIC basically is a computer sitting in front of another computer. So rather than having just a card as an I/O, moving packets, we make it more dedicated to specific workflows. You will find many SmartNIC equipped either with an FPGA, embedded ARM cores, 8, 16. Those seem to be much more efficient in doing some compute. They don't run at the same frequency as well, and they are more light. But the best thing about SmartNIC and the way we're going with this, that it's specifically dedicated to some workflow. So many of the functionality that we used to do in software Now we took it to the hardware in order to reach the same performance number that we wanted to reach, but at the same time, we don't eat as much of the CPU. SmartNIC would have something like an FPGA. It would have specific chips to do some acceleration as well. There's all sort of acceleration and functionality that are dedicated for those workflows, which is different than having just everything run in software on top of your CPU. A typical example for is SmartNIC. You would see some interfaces for DDRs to the memory. That would to allow kind of separation from a host machine. The host machine have its own memory, and then the network adapter would have its own memory to store all the context that it need. In case of security, this guarantee you isolation. The network adapter, if you have embedded compute like ARM cores, you'll be able to run your own operating system and interact with the hardware and use the hardware to implement your own application. They're also equipped with a network adapter, and the network adapter basically does all sort of fancy functionality that is not available in every network adapter, like offloading the IPsec or offloading TLS, firewall rules, and so on. Okay, and we've seen this changing through the years. This is not completely different, but it did, if you see the evolution of how we started from a normal network adapter and we moved to smart network adapter. We started with having everything in the hypervisor. That means more CPU cycles and much less network work on the NIC. Then we moved on. We started offloading some of the functionality like network data plane and storage virtualization. So you don't need to have actually a storage device connected to your server. That will all be facilitated by the network adapter, where it can, your storage system can sit somewhere else, and your network adapter completely emulate all that for you without much involvement of the hypervisor. Now, the interesting part here is more we're looking at security. This is more becoming a thing to do security because of all the latest vulnerability in the last 5 years. Even if you don't have any malicious code running on your host machine, someone will still be able to exploit software. But what we found out in the last 5 years, that also hardware can be exploited on a host machine and eventually can gain control. So isolating the security control from the main machine where you're giving the services and the user is getting important. And here where I'm going to talk further more about the kind of application you can run on a SmartNIC. So if we're looking at data centers and edge, this is the kind of component that from the application level to the hardware level that you want to have in place. So for the security application level, you have application like intrusion prevention system, intrusion detection system, deep packet inspection. Some people might want to use a device to do memory forensics or malware analysis. We're getting further down to the hardware level. We look at things like firewall and offloading things and offloading things from the kernel directly to the hardware to do all this policy like Open vSwitch and other. The cryptography, the same thing. If you look at a system that, example of a system that running IPsec for all the connections of VM, out of 8 cores, you have 1.5 core basically completely dedicated for running IPsec encryption. That's not exactly optimal. With SmartNIC, this can be completely offloaded and designed in the hardware, in the chip themselves, to offload this operation. That means you can reach much higher speed and you can reach the same performance number that your network adapter can support, like 100 gigabit per second. And of course, now that SmartNIC are getting much more complex, we have an operating system that is running there, all sort of programmable hardware. There's going to be some work with the keys. We definitely don't want SmartNIC to become the point where someone else's uses to attack the system. So we're going to have to think about how we secure this system in a similar manner how we secure our host machines. Because if someone breaking there has access to memory, to the network packets, everything there. So we have to secure that as well. And in order to achieve that, we have to have the hardware primitive in place, not only rely on software, because again, we're going back to the concept of zero trust. I really don't trust anyone that is present, like an admin or external user. And I want to guarantee that when I load my system, I know that it's loading from a good, clean state. So SmartNIC actually, if I classify it, it can be classified into two different directions. One for performance and gain for designing basically a good infrastructure that is not as much heavily using just CPU. So reducing the cost of the platform that you're building by having dedicated hardware that do some of this operation acceleration. And that's come about mostly in offloading the encryption for both data at rest and data in motion, and at the same time complete isolation from a host machine. The other approach where SmartNIC are taking is for endpoint security. This SmartNIC is going to be connected to a server, and I want to enjoy this compute in order to make sure that my server, my endpoint, whether it's a hypervisor, virtual machine, is still running and doing the same behavior I expect it to do. So if I expect a specific VM to run 7 applications, those specific applications, I want to guarantee that it's whitelisted, running those processes, running those kernel models, and that's something that also can be achieved with SmartNICs. It all starts with the hardware root of trust. The first element I talked about is securing the platform. And a SmartNIC is a bit more complex than just a host CPU because it has many specific devices on board in order to accelerate some of the functionality. So in typical SmartNIC, you will find at least 2 subcomponents that run 2 separate firmware, and you'll have another component running an operating system, and all that need to be working together in the same chip and guarantee that it's running a good software and a good firmware. For the user point of view, you want to have the guarantee that if you are running a software, this software is coming from you. So you want to have the programmability that you are able to embed your own key and guarantee that only the software that is basically signed by you, cryptography, can run on this platform. And of course, we have to guarantee also this is aligned with all the specification because we can't implement everything from the beginning and come up with a new paradigm. We have to rely on what is available out there by NIST, like SP800-147, which describe the mechanism for BIOS protections and platform protection and resiliency. So the first one case that I want to talk about is connection tracking. Connection tracking is related to the network as well. And with connection tracking, the idea is if I let my host machine, if I'm working in accelerator mode, and I say I'm trusting my hypervisor, I will let the hypervisor come and program the device and say, here's a new connection that started, here's the connection state, here's the TCP windows, and I can insert any rules or any policy that I want into the network adapter. And this is different than having all this as part of the kernel or having this running on top of the operating system. Because this is all offloaded as part of the hardware in order to support inline rate like 100 gigabit per second. So it's completely different than the current approach that we have. This is not the only mode that basically supported. The other mode that can be looked at in case of you don't really have access to a software that is running on the machine and you don't really want to trust whatever running on a host machine, you can have this completely transparent. So if you have some, as I mentioned earlier, you have some compute where you're running your operating system and you can mirror all this traffic, try to detect it in flight, and then basically configure all these rules in your SmartNIC to go and enforce it. The second case, and the more typical case, is the IPsec inline encryption. And the idea here is to kind of still meet the 100 gigabit per second line rate and offload most of the functionality from the host CPU. And now, with IPsec, the important part here is once we establish the connection and we know what is that key that is going to be used to encrypt all this traffic. That could last for seconds, it can last for a minute, and sometimes even it lasts for hours. It really depends on the policy. In this case, I don't want to even take 5% of my CPU or 10% of my CPU to do any of the offload. And with offloading this functionality, you can completely clear the CPU to run everything else, and the encryption can be in the right place and in the network where it can completely offload it from the CPU. And here we need to talk about two modes, right? This is like what I mentioned earlier. There is the accelerated mode, and there is the mode of transparent mode. What does it mean, transparent and non-transparent? So imagine a case where you have multiple virtual machines running on your server, but you want to make it completely transparent from the virtual machine. You don't want those virtual machines to know, if you are within a data center, that is actually encrypting the traffic. You want everything to happen on the SmartNIC. So that's very much possible, but then it also complicates the system because there are some aspect of keys that I need to deal with. I need to generate a key now in order to establish that connection from SmartNIC, and that requires more elements in place. I need some key management. I need some cryptographic accelerators. I need to have a true random number generator in order to be able to generate those keys. And SmartNICs need to accommodate to that and have all those primitives in place while still complying with policy. Any questions? The next application is deep packet inspection. And with the deep packet inspection application, it's quite complicated because, again, if we are taking everything to software, that takes and burn a lot of cycles and take a lot of the CPU. So with deep packet inspection, you can move the data from the network adapter, operate it on the way you want on the operating system at the application level. But for that, you also need a lot of hardware accelerators in order to optimize this process. You need to make it faster, lower latency, and you need to handle the 100 gigabit speed. And for that, you have to have some embedded hardware accelerator in place that can facilitate that. And that includes agents. Agents today mostly running on a host machine, either as part of your hypervisor or as part of your VM. All this taking CPU cycle, but at the same time, it's also risky to have all these agents running. If someone infiltrates your system or have an exploit there and manage to shut down your security solution, there you are in a problem because you really don't know if a malware or whoever infiltrated your system is basically able to completely bypass your agent that you have in place. So with a SmartNIC, now that you have an operating system in place and you have many of the hooks that allow you to collect the data that you need, you can now move your agent from your host machine, isolate it as part of your SmartNIC compute, and completely isolate it from the same network that is used for the user. And again, another component in place to do that is to have some sort of side management interface, different network that is isolated from the user network. So if we look at the SmartNIC and the future for how this is used, it's going to be a lot of new hardware in place coming on those in these cards in order to make it more profitable, less power consumption, and designing infrastructure that is less reliant on just software but also dedicated for specific workflows. It's going to be more secure because it allows isolation of the security application from the rest of the system. It will include FPGA, as I said, regular expression for deep packet inspection, and enjoy the same functionality of the network adapter. Thank you.
Questions for Ahmad?
Yeah, Andy Parsons, CenturyLink. Where would be the sort of the break even in these cards between like a dedicated device, or sort of multifunction or firewall?
Say that again.
Where would be the break? What's the sort of the difference between sort of moving these functions to the NIC over having, say, a dedicated device sitting separately to the hosts? Is there a break point where it becomes more cost effective to have it? You know, obviously there's different benefits to the configuration, but from if you're looking at somebody who's just going to be buying a security solution, how would this compare against a separate security box?
Yeah, so in high-performance system, right, if you care about the latency, you need to think about the number of hubs. If you have dedicated hardware in place just to do this kind of firewall aspect, you will have the hub from your system memory to the device, back to the system memory, and then out. The beauty about the SmartNIC, this is already part of your path of going out, right? So there's no additional hubs. So there's no hub from your memory to, let's say, SmartNIC memory and so on. This is all part of your data path. The control path is configured at some point, and from that goes to all the hardware. So it reduces the latency by miles for you. Did I answer your question?
Kind of, yeah. I was sort of thinking about it. So the performance, I kind of get that. I was just sort of, if somebody's looking to set up a system and they're looking at the costs of doing that. I mean, if there's a break even between sort of doing it with separate boxes or doing it here, I was sort of wondering what the commercials are against sort of separate boxes.
There's more software involved. There's more complexity involved because the interfaces are going to be different because of the different hubs. Here's more the configuration for SmartNIC. In my opinion, it would be easier, and the interface basically as a result will be easier as well.
So it's reducing operational costs.
It's reduced operational cost. I mean, on the latency and performance side, there is improvement, as I mentioned. But because you need to move less data and do less configuration and handle less cases in software, because this is mostly kind of like encapsulated in a way that the hardware will deal with it, it will make it simpler.
Thank you.
Okay, thank you, Ahmad.